Good morning, everyone, and welcome to today's webinar sponsored by Rootstock Software. Our last topic was engineering. Learn how to create part master records and bills of material. This is the third webinar in our ERP 101 webinar series. Our topic today is engineering. Learn how change orders and/or revisions ensures that ERP system data is accurate and up to date. Moving on to some housekeeping. Before we get started, I'd like to go over a few items so you know how to participate in today's event. We've taken a screenshot of an example of the attendee interface. You should see something like this, something that looks like this on your own computer desktop in the upper right corner. You're listening in using your computer speaker system by default. If you prefer to join over the phone, just select telephone in the audio pane and the dial-in information will be displayed. All attendees will be on mute throughout the presentation. You'll have the opportunity to submit text questions to today's presenter by typing your questions into the questions pane of the control panel. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentation. Now we'll take a look at our upcoming schedule. Today we will be covering engineering. Learn how change orders and/or revisions ensures that ERP system data is accurate and up to date. The next webinar in the ERP 101 webinar series by Rootstock Software is scheduled for October 11th and will cover the topic Shop Floor. Explore how ERP is used to create and maintain work centers, routings, and procedures. Future webinar dates are to be announced. I would now like to introduce our presenter, David Bush, Senior Manufacturing Consultant at Rootstock Software. David Bush has 30-plus years of manufacturing and MRP ERP systems experience. David was previously at General Microcircuits, Consona Corporation, and Relevant Business Systems. David will now introduce us to engineering basics. Hi, David.
Hi, David, and thank you very much. Appreciate that introduction. In our last couple of webinars, we discussed ERP in a general sense. We talked about its history. We talked about the fact that it had evolved from basically a bill of material system to a material requirement planning system to today's enterprise resource system that is so popular now. In our past session, the last session, we talked about how part numbers are an integral part of the ERP system, that they actually form the foundation of the system that most everything else is built on to a very large degree. We also discussed part numbers in detail. We talked about things like the format of the part number, the fact that some companies and some individuals have decided to use what's called an intelligent or a smart number, which incorporates aspects of the item itself in the part number to make it simple in especially a spreadsheet type of system to find those part numbers. But in the modern ERP systems, it is so easy to find part numbers based on other criteria like the description and things like that, that using intelligent part numbers we found was not the right way to go. So what we're doing is encouraging people to not use smart or intelligent part numbers. We also discussed the description, the need to have some format to that description so that when you're searching for something, you know basically what the format of that item's description might be and makes it much easier to find it. We discussed units of measure and found out that units of measure can be different in various segments of a company. For example, the engineers might use a unit of measure of inch when they're designing something. That same item might be kept by the foot or yard in inventory, and it might be purchased by the roll or carton. So we discussed to some degree how those units of measure are used, but when we get into our inventory discussion later on in a later webinar, we'll talk more in depth about that. We discussed the source of part numbers last time, the fact that they can be either manufactured, purchased, or a combination of the two, which is subcontract, where parts are sent to a vendor who takes those parts, possibly adds more, certainly adds labor, and then returns a different part number. We also discussed the fact that parts can come in different types. They can be standard, for example, which is the normal part you would think of as it gets used in the manufacturing process. They also might be reference items. For example, instruction sheets, blueprints, things like that. Or they could even be phantom part numbers, items that are built during the manufacturing process but not ever planned on their own. Then we talked about the fact that all of these part numbers get put together to form bills of materials. And for those of you who had joined us in the past, you'll remember looking at the example of a bicycle and how it was blown up into its many various parts, but those parts came together in a bill of material structure to build the end item that would be shipped to the customers. So let's talk about bills of materials just to recap this a little bit. And this is important because it will help us better understand the topic for today's webinar. So bills of materials, known as a BOM, are comprised of multiple levels. The lowest level is always raw material or purchase parts. The top level, the item that is being built or being shipped to the customer, is always at level 0. The bill of material includes components, which could be individual parts or sub-assemblies, or it might be tooling or fixtures. It could even be reference items. All of those things can be included in the bill of material. Then we also discussed scrap factors and setup quantities. We learned that you can't just look at the number of a component that needs to be used in a parent item, but you've got to look at what may be lost in the manufacturing process through scrap or through setting up machines that are going to perform various functions in building that end item. So our hope is that by the end of our last webinar, everyone had a good understanding of both part numbers and bills of materials and how they fit together to form the basis or the foundation for the ERP system. But you might remember that at the end of the last session, we were left with some very important questions that still needed to be answered. So what additional considerations about part numbers and bills of material could affect material planning, the MRP part of the ERP system? As you've seen, we have our part numbers. We've put them together into that bill of material structure, and our bill of material has identified the specific quantity that's required to build the next higher assembly, whether that be a sub-assembly or the finished goods. And then we've even gone so far as to adjust that quantity by those various factors, the scrap factors and setup quantities that we talked about. So what else could affect the MRP system and its ability to plan properly? Well, the problem is that nothing ever stays the same. So what happens when changes occur? Well, those questions come up because new styles are offered. Perhaps the customers have driven the need to change the format of the item that's being sold. Maybe they want new colors or new designs or whatever to keep up with current desires. There may be safety features added, and these might be promoted by either the engineering department that designed the item or outside forces that are requiring safety features. Or maybe you've gotten in touch with your vendor to place an order and the vendor says, well, I'm sorry, but those parts aren't available anymore. We do have replacement parts, but we don't have those parts anymore. So what happens when old parts from a previous design are no longer available? What happens then? What do you do? What happens when the changes are subtle or even major changes to the final assembly? How do we control changes that affect the ability to plan the material that's needed? Well, those changes are planned and controlled through revisions and engineering change orders. We're going to talk about in our session today what revisions and what engineering change orders actually are, what's the difference between the two, and why you might decide that they're important for your own company. So let's talk about first revision control, engineering revisions. Engineering revisions are typically an alphanumeric identifier of a specific change or adjustment to a part or an assembly. So I've given a couple examples of what a revision might physically look like if you were looking at a document that contained a part and revision. Typically, when a part is first created under revision control, it is assigned automatically revision 0. And then the next revision might be revision 1. It could be revision A or A1. Typically, after revision 0, the user has the ability to assign the specific revision number, but it must be in alphanumeric order so that the system has a way of knowing which is the newest, which is the oldest, and so forth. A revision is actually a documented change to a part or a subassembly. Examples might be where a revision is needed would be beefing up a part that has additional hardware added, or maybe a heavier weight of steel is going to be used. Maybe new colors for the final product are going to be added. Some colors might be done away with. Or there might be some other more subtle changes to components or subassemblies that are being used to build that final product. The change itself might be minor or it might be very significant, but it would not affect the form, fit, or function of the item being changed or the subassembly that's being changed. What that really means is that if the form, fit, or function of the item does change, then you'd rather think about a new part number for that item instead of a revision of an old item. And there's various reasons for that, which we'll talk about in just a few minutes. The engineering revision may be prompted by sales, or maybe a better way to put that would be by the customers that sales is dealing with. It may be an engineering design that for some reason needs to be changed, maybe to save money, maybe to make it safer, maybe to make it more robust. Or it could be, as I said earlier, availability from the vendor ends. The vendor says, we do not supply that part anymore, it's not available anymore, and we do have a replacement part, or maybe some other part has to be designed. Regardless of the reason, revision control is a formal method that a company decides to use to control the change that's happening and the effects that it can have not only on the bill of material and on material planning, but perhaps in manufacturing, certainly in sales and in other areas of the company. So what exactly does an engineering revision control? Well, it certainly controls the status of the revision itself. The status is typically one of three: a pending status, a release status, or an implemented status. Pending is often used by engineers to kind of be a holding place for parts that they're playing around with. Maybe they're redesigning, they're changing it in some way, but they're not ready to sign off on that change yet. So this allows them to create bills of materials in a pending status, with parts in a pending status that will not affect the MRP system. Released is typically used, this status released is typically used by companies to release the change that engineering wants to put into practice, into play, to other areas of their facility. It's not released to manufacturing, but rather they might send a part change to purchasing and ask the purchasing department to sign off on that and say, yes, we can get this part, and maybe to finance to see if it's going to be cost effective to make that change. These department sign-offs are typically done outside of the system under revision control. In other words, the ERP system does not maintain who has agreed to it, who has signed off on it, but rather it maintains only the pending, released, or implemented status at the engineering level. So companies that use revision control often will use a manual system to send this information out to the various aspects of the company and wait for it to come back, and then engineering releases or implements the change. The MRP part of the ERP system, the Material Requirements Planning part, only recognizes the implemented status. So why use the pending and release status at all? What benefits come from controlling these statuses? Well, the revision status clearly tells MRP what to plan, only if it's an implemented revision. So, as I said, the engineers can use the pending and the release status to control what happens to these parts before MRP is going to actually take over and plan them for the manufacturing process. Revisions can happen at any level of a bill of material, from the bottom level of purchased parts all the way up to finished goods. But what if the revision is not to change parts, not to make changes so that it evolves from one part to another, but it's to add or delete parts? How is that going to be handled? Now, this would be like something I mentioned a minute ago about a vendor who says that I can no longer supply that part. I now have a different part. Well, you wouldn't have much need to put a revision on the old part if it's not going to be used anymore, and you don't need a revision on the new part because it's brand new. So how is that going to be handled? Well, one option that would cause this would be the part's no longer available for purchase. It's been replaced with a new part. It could be that other options have been added and some options have been deleted. Well, in a case like that, a revision is still something that is required, but now another feature of revisions comes into play, the date feature. Revisions not only have a revision number, like the 0 or the A that we mentioned earlier, but they also have a date, a revision date, and a delete, an add revision date and a delete revision date. And perhaps if you think about this for a few minutes, it becomes clear why this would be necessary. So as parts are phased in and phased out, the system needs to know, well, which part am I using today? Which part is viable on the bill of material? Which part needs to be purchased and sent out to the manufacturing floor? So it not only uses the current revision, but it uses the add and the delete revision dates to do that. So let's think about an example. On our bill of material, part A is being replaced by part B, or a revision is needed for both parts. Part A is going to have a delete revision, which will only consist of the date that that part will no longer be used, and part B will have an add revision, and both of those will have the same date. So the day that part A is no longer needed is the same day that part B will start to be used. It's just that one has a delete revision date and the other has an add revision date. So remember the bicycle that we've been talking about in the past couple of webinars. Let's look at that as an example of why this might be done. Let's say that the braking system, the calipers on the braking system for our bicycle need to be adjusted for some reason. Maybe there's a problem with the brake pads. And so the engineers have looked at it and they've decided that the old rubber pads dried out too quickly and got smooth and no longer function properly as they were designed. So they've decided that they're going to replace the fiber pads with, the old rubber pads with new fiber pads on this assembly. Now, you might remember from our previous session that the brake calipers are a purchased assembly. This whole thing is bought from a vendor. So how would revision control be used? Would it even be needed? And what issues would have to be handled? Well, here we have that same picture, a blow-up of that brake assembly, and it's these pads right here that are being replaced. And the question comes up, is a new part number required, or can it be handled via revision control? Well, since this whole unit is purchased, the company may decide that a new part number is not needed, that the old parts with the rubber pads are still going to be used until they're all gone, and then we're going to switch to this new assembly. Or it may be that the engineers decide we do need to have a new revision for the assembly that indicates that now these fiber pads are going to be used, and then that revised assembly drawing gets sent to the vendor so that they can be sure that the right parts are being used. So a revision would be created at the purchased part or the brake assembly level in this case to indicate what components are going into this revision of the brake assembly. So they would have to determine how the change is going to affect existing stock and purchase orders. Will they, for example, will the old ones be used up and then switched to the new assembly? Will they be scrapped? Or will they be reworked by your company or perhaps by the vendor? Now, what would constitute the answer to that question? Well, go back to A again. Will they be used up and then switched to the new assembly? What caused this change to happen in the first place? Is it simply to make a better product? Is it maybe a cost reduction issue? Is it to resolve a problem? And if it is to resolve a problem, just how serious is that problem? Is it something that you can live with until the change comes through, or is it something that needs to be changed right away? Well, the answer to those questions will answer this question: will we use up what we've got and then switch to the new assembly? Or perhaps going down to C, will it be reworked by you or the vendor? If you have a lot of these brake calipers with the old rubber pads and they can't be used anymore, are you going to send them back to the vendor to have the vendor replace those pads? If so, what will the cost be, if any? Whose responsibility is it? There are many, many questions that have to be answered that are prompted by this revision. And it may be that the old ones have to be scrapped. Maybe those rubber pads can't be replaced, depending on how they were mounted in the first place. So there's cost considerations there. But in any case, it becomes clear that making a revision requires the answer to many different questions from many different areas of the company that could possibly be affected by this revision. So here's an important consideration too. Revision control does not control physical inventory. That's done at the part number level, not the part number revision. So if you were to look up a part on your ERP system to see how many of them do you have in inventory, in most ERP systems, while you may be shown the revision of quantities of this part, it typically is going to lump them all together. So it might say you have 100 of this part in inventory, and just from that information, you don't know what revision those parts are. Remember, inventory is kept at the part number level, not part number revision. That's why it's possible to have different revisions in inventory of exactly the same item. So material control must be involved, and there are many ways that material control can handle this. There are many ways that the ERP system can handle this as well. As I say here, the ERP system may track revisions in inventory, but that's a discussion we'll save for another day in another webinar on physical inventory. But what if more control is required? What if those informal sign-offs that I mentioned, where the packet is being sent to the different departments and somebody's signing off on it and putting a date and saying, yeah, we agree, we can do this, and they go back to the engineering department, and then engineering goes into the ERP system and approves or implements the change? What if that just doesn't cut it? Well, now we move into engineering change orders. Engineering change orders work in conjunction or along with revision control. They don't replace revision control, but they work with it to provide a more formal system to handle change. So you might think of engineering change orders as being an umbrella over the revision control system. They guide and protect each revision. The main difference between the engineering change order and revisions is a formal sign-off by various departments before the change can be implemented. So typically the ERP system will have assigned specific individuals who have the ability to okay an engineering change order. And every one of those individuals who is in their various departments in the company have got to sign off on the change before engineering can implement it. So the item itself still gets implemented. It still goes through the statuses of pending, released, and implemented, but it does it at the engineering change order level instead of the revision. And so now we would have a history of, well, who said it was okay to do that? When did they say it? And what was the status of the item before that? And all of that information is then held at the engineering change order level within the ERP system as a result of using that functionality. So as I mentioned, individuals are typically given the ability within the ERP system, no longer outside of the system, to create and maintain those engineering change orders. Yes, sign-offs are required with the system giving individuals that ability by engineering, material control, purchasing, and maybe other departments that are going to be affected by the change. That basically is the difference between using engineering change orders and just revisions. It might not seem like much, but you are adding a lot of overhead, but you're getting a lot of additional information as a result of that added overhead. So in review, what have we covered in today's webinar? Well, we know that change is inevitable in the ERP system, and the revision or engineering change order systems are designed to handle those inevitable changes so that the MRP system always plans the correct items in the correct quantities. We learned that revision control is a less formal method, but still requires status changes from pending and release to implemented, along with dates that those status changes take effect. Engineering change orders incorporate all of the features of revision control, but they add that more formal system sign-off area within the ERP system. So engineering change orders become the controlling mechanism. So we've discussed parts, we've discussed bills of materials, we've discussed controlling those parts and bills of materials through revisions and engineering change orders. Where does our webinar series go from here? Well, as David mentioned at the outset, our next session is on shop floor control, where we'll be discussing work centers and processes and operations. We'll talk about subcontract operations that are done outside of your facility, setup and run considerations, scheduling and reporting labor and time used on machines. So we'll be moving away from looking so pointedly at material to now how is that material actually put together and formed into an end product that we can ship to our customer. And that's our next webinar. David, back to you.
Thank you, David. Okay, impressive job as always. Okay, folks, before we get to your questions, just a quick reminder that this webinar will be posted on our website at www.rootstock.com. And of course, after the webinar, if you have any further inquiries, please email us at marketing@rootstock.com. We'll now move on to answer questions submitted during today's presentation, as well as take any new questions. And just a reminder, you can still submit questions through the questions pane in your attendee control panel. David, we do have a few questions that have come in today. Let me start with the first one. How do I decide if I need a new part number or a revision?
Okay, so remember we talked about fit, form, and function. Normally, if a part cannot be, if the new part cannot be used interchangeably with the old part, you would want to have a new part number. So if the change is color, for example, well, color probably is interchangeable. If it's a change of thickness of metal, that may or may not be interchangeable. if there's a new drill hole pattern in it, that may or may not be interchangeable. So it's on a part-by-part basis. You can't give a kind of a blanket answer to that question, but say each item has to be looked at individually, and if it can be used exactly the same as the old part, then you would not need a new part number.
Okay. We'll move on to our next question. If I ordered a purchased part that has been revised, how does the vendor know there has been a change since the last order?
Under revision control or engineering change control, the purchasing department is informed either formally through the ERP system or informally that a change has been made. The vendor would then have to be notified by the buyer indicating that this change has happened, and of course the engineers would have to tell the buyer whether the old parts that are on order should remain on order and be used up, or whether that order needs to be canceled. There's obvious financial implications here if an order has to be canceled, possible financial implications I'd say, but typically it is done through the buyer informing the vendor of the change.
Okay, excellent. Two more questions coming, David. If our company has more complex needs than you discussed when it comes to controlling revisions and engineering change orders, possibly in the documentation area or for parts outside of the company, or for parts of the company outside of manufacturing, what can we do?
That's a good question, and it's a question that often comes up from government manufacturers, individuals, companies that are manufacturing items for government purposes, because their requirements are very, very stringent. Typical engineering change order or revision control in ERP systems often will not handle the depth that is needed by those companies. And so there are third-party software packages. Propel, for example, is one company that is partnered with Rootstock to handle much more in-depth needs to revision or change control when a company deems that necessary.
Okay, excellent. And our last question is a two-parter, David. Can part numbers be tied to a file? For example, a PDF. Hold on, another question just rolled in. Okay, let me start that over. Can part numbers be tied to a file? For example, a PDF with blueprints or a .iges file? And if so, when the PO is sent to the vendor, can the system be configured to send the PO and attach some of the files the part numbers have attached to it?
Absolutely. That is something that's very commonly done. The modern ERP systems all have methodology to do that. So as a matter of fact, part of the engineering change order or even revision control systems can be to see if the part is a purchased part and automatically send that change information to the vendor if that seems to be the necessary course to take. So yes, the answer is yes to that question.
Okay, great. And we're going to move on to one more question that just came in. The question is, expanding on your comment regarding when a new part number must be created, are you saying if a part is backwards compatible, although presumably better and preferred, it is acceptable to create a revision of the existing part number? But if the revision is not backwards compatible, then new part number should be created. Is that correct?
That is correct, yes. Probably a more succinct way of saying it than I said it. If the part can still be used exactly the same way the previous part was used, then you don't need a new part number necessarily. Of course, sometimes that is the company's decision, whether they want to control things with revisions or with part numbers. But the purpose of today's webinar was to discuss how revisions and engineering change orders can be used for that purpose.
Okay, great. Thanks, David. We're going to move on now. Thank you, everybody, for your questions. Those were great. Before we end today's webinar, I'd like to present a brief look ahead at the upcoming topics in our ERP 101 webinar series. Today we covered engineering basics, learn how change orders and/or revisions ensures that ERP system data is accurate and up to date. The next webinar in the ERP 101 webinar series by Rootstock Software is scheduled for October 11th and will cover the topic Shop Floor. Explore how ERP is used to create and maintain work centers, routings, and procedures. Future webinar dates are to be announced. Thank you for joining us today. We look forward to seeing you at our next webinar. Today's webinar is now over.